relation and functions. So the Cartesian product is the first part, and we need to understand how to pair objects from two different sets when we talk about relations. Imagine we have a set of colors, red and blue, and a set of objects, bag, coat, shirt. Cartesian product is simply every possible way to pair a color with an object. So it's like a menu from column A to column B. Ordered pairs, we call it. Now moving on to the relation. So what is a relation? A relation is just a specific rule that picks certain pairs out of that big Cartesian product. In daily life, we have relations like father and son and teacher and student. In math, it might be is less than or is the square of. Usually, we represent this with an arrow diagram, and it shows exactly which element from the first set points to an element in the second set. So the special rule functions. Now a function is a very disciplined type of relation. Think of it as a machine. You put one input in and you get exactly one output. For a relation to qualify as a function, two rules must be met. First, every single element in the first set must have a partner. Second, no element in the first set can have more than one partner. It is a one and only one rule. So that is the notation and the definition and visual check. Next, the common real functions and their graphs. So like for example, there can be identity function, which is like a mirror. The output is exactly the input. The constant function always gives the same result no matter the input. Creating a horizontal line. Then there is the modulus function, which acts like an absolute value machine, turning every number positive and creating a V-shaped graph. Now the algebra of functions. Finally, just like numbers, we can add, subtract, multiply and divide functions. If you have two functions f and g, you simply perform the operation on their outputs. The only catch is when dividing, the function in the denominator cannot be 0.